Hello, my name's Deryn and I primarily worked on the back end of the GlobeStepper app.
Hello, I'm Carla and I work mostly on the front end of the app. So for our project called GlobeStepper, we wanted to create an app where users could track the distances they'd walked against well-known routes across the globe. The reason for this is that many of us are familiar of the health risks of a sedentary lifestyle and also the recommendations to combat this of at least 30 minutes moderate physical activity a day. Our thinking was that by having an app where users had a specific goal in mind, it would give them increased motivation to form good habits, to get out and move more, and ultimately get the physical and mental health benefits of this. We also wanted in the app to have a variety of different routes for users of different levels of fitness. We adopted a range of tools to help us build the GlobeStepper app. In the early stages, Figma was particularly helpful in brainstorming ideas and deciding which were our priorities to make sure we had a minimal viable product. We both wanted to use Trello to help us break down the tasks into smaller parts and decide who was working on individual tickets. That really helped at the start from feeling overwhelmed as to where to begin with the project. For GitHub, we had front-end and back-end repositories and used branching regularly, but it particularly helped in the later stages when we were getting our front-end and back-end functionalities working together. In terms of communicating, we were on Slack daily and used Google Meets every few days, where we would often pair program if one of us was blocked. That really helped on more than a few occasions. The front-end was built using the React framework, supported by React testing library to test out the components, and also I installed React through to DOM as well to help with client-side routing so that the user can navigate between different pages without reloading. It was also done with future scalability in mind because it would allow for nested routes and route-based code splitting for lazy loading if there was particularly image-heavy components, which potentially the challenges would be as more were added. Axios was used to handle HTTP requests to the backend database, and I also included Chakra UI component library. This helped to ensure that the design was consistent across components, and it also has responsiveness and accessibility built in, along with some pre-designed components which help to save time on the design. Because our app needs to render user-specific information on the client side, like a user dashboard, tracker and achievement badges, I wanted to create an easy centralized management of the user authentication state throughout the app that would make it ultimately easier to maintain. The auth reducer is a function that handles state updates from the auth context, which was created using the built-in create context function from React. This creates a new context object that can be used to store and access global state from within the application. So the auth reducer then takes in the current state and two types of actions in this case, login and logout, so that when the login action is dispatched, the auth reducer updates the state with the user information and will remove it again on logout. We then have an auth context provider component that was made as a higher order component, and that wraps the rest of the application so that it provides access to the auth context and its state from any component wrapped inside it without the need to have to pass props down the component tree, which ultimately helps make the code more readable and less prone to bugs. You can see here how auth context provider is wrapping the whole of the app. I also mentioned about using the Chakra UI component library in earlier slides, and you can see here how that is also imported and wrapping the entire application so that it can be used. And an example of how we used it was in the challenge cards component, where we imported specific aspects from the component library that had a default sort of styling that could then be rendered inside the component. So here's an example of the client side of our application. So here you can see the Chakra card components rendering that we saw in the previous code. At the moment we're not logged in, so if we were to try to join the challenge, we are directed to log in. If you weren't a user already, it directs you to the registration page instead. But as I've got an example user to show, we'll just type that in. We've got a successful notification. The state's now being updated, and you can see we've got access to the dashboard component. This is where the user can see their chosen challenge and the progress that they've made so far, along with the distances. They can update and post further distances in to recalculate the totals, and they can also see a list of all previous entries as well. So then from the dashboard, the user can select to log out, and it would take us back onto the main page.
For the back end of our app, we created an Express API using Postgres to make our relational database. We use SQLize to manipulate and add data to our database without the need to write SQL queries. We created a container for the database using Docker and used Mocha, Chai and Supertest to test our code. For user authentication on sign up and login, we used JSON Web Tokens to create user authorization credentials and used bcrypt to hash the user's password. Using JSON Web Tokens also allowed us to create a token for the local storage so the user could navigate the app while still logged in. When designing our app, we determined that we would need 3 tables for our MVP: the user, progress and challenge tables. The challenge belongs to the user and the progress belongs to the user. The progress also belongs to the challenge. A user is created in the database when they register. A challenge is created in the database when the user selects Join the Challenge, and the progress is updated when the user posts a distance that they've walked. So from the home page, once the user has joined the challenge that they want to take part in, they can go to the dashboard, and the dashboard makes a request to the database for the challenge that that user has joined and brings back the title of that challenge and the image associated. It also brings the total distance of the challenge that's been selected. The user can then scroll down to post a distance that they've walked. And once the distance has been posted, it will update the total distance that they've travelled, the remaining distance that they have, and show them visually the percentage of the challenge they have remaining. The user can then scroll down and view all the distances that they've posted into the database and on the date that they were created. When making the app, we did come across some challenges. The biggest challenge we found was time, in making sure that we had enough time to get the MVP of our app up and running, and missing out on the opportunity to get some of the nice to haves in our app. We faced a challenge with our user authentication and looked at some alternative technologies than those that we'd learnt on the course, such as Supabase and Firebase. We ultimately decided to use the technologies we'd learnt on the course to get our user authentication up and running. We did face some issues with our server connection, but discovered that this was because we'd named something incorrectly. We did also face some node module issues, but were able to revert back to a previous version of the app through GitHub to make sure those issues didn't continue. We'd love to improve our app by using some more test-driven development, and for the user experience we'd like to include achievement badges which would sync up with their progress and appear in the user dashboard, allow the users to share challenges together and compare their progress with friends, update the dashboard with pictures and information of their selected challenge at particular milestones, and look at the possibility of syncing data from external apps such as Strava, Apple or Garmin. And lastly, we'd like to say a really big thank you to all of the tutors and staff at Command Shift and to our fellow students in the September 22 cohort for all of their support along the way. There are links here to view our code, and if you have any questions, please don't hesitate to reach out to either me or Carla. Thank you for taking the time to watch this presentation.